I actually originally came to Northeastern as a bioengineer, but when I was exposed to security related projects in my lab, I became really interested in that. I originally wanted to focus on medical technology because I felt like it was the easiest way to make a positive impact on people directly, but then I realized that I could do the same thing with security projects, and I was a lot more interested in them. Hi, my name is Katherine. I am a third-year mechanical engineering student here at Northeastern. I work in the Seeker lab on a on-the-move threat detection system project. My first year at Northeastern, I got involved with the Alert Gordon Census Scholars Program, and through that, I was working on a burn tissue imaging project in the Seeker lab. And after that program was over in my first year, I got involved with the Alert SODEP program and continued in the Seeker lab working on my current project. We noticed a problem in current human security screening systems where they either don't screen enough, like the easy metal walk-through detectors at TSA, or they are too slow. So my role in this project is as a mechanical engineer. The rest of the people on the project are focused more on the physics or the electronics of it. And as a mechanical engineer, I have found ways to manufacture the parts that are a lot cheaper than traditional manufacturing. So for example, one of the reflectors that would traditionally be a couple tens of thousands of dollars, we instead 3D printed it and metallized it with a silver spray, so it only cost a few hundred. Hi, we're in the lab now. This is Professor Jose Martinez's Seeker lab. This is one of our first prototypes of the imaging system. Our eventual goal for the system, which we hope to complete within a few years, is making sort of a larger arc where people could walk through and threats can be detected on the people in real time. This is our perturbed cavity antenna. The electromagnetic waves come in through that hole there. It bounces around the chamber. It bounces off of that quarter sphere, which makes our antenna unique. It really helps to randomize the waves, and then it comes back out of those holes onto the imaging subject, then to the compressor reflector antenna, and back to the focal point. These are our compressor reflector antennas, or CRAs. This is what I mostly worked on throughout the project. The point of these is to randomize the electromagnetic waves to create more channels of information so that that information can be transferred quicker and we can image the person quicker and make the whole system faster. We made these using the 3D printing manufacturing technique and coated them in a silver metallized spray to make them reflective. So when I started working on it, I was just starting to make that compressor reflector antenna. We did not have one of those before. We were really focused on the individual elements of this system, and where the project is at right now is we have that big system built that is set up to image a whole person. I am the mechanical engineer on this project, so I work on the antenna and the reflectors and fabricating these parts. There are also physicists and electrical engineers who deal with the rest of the system, programmers who work on processing the data, and then it all comes together into a cohesive working system. Some of the highlights have been learning to work with such a diverse team of other researchers with other specialties. So much of the project I honestly don't fully understand because it's a lot of physics and a lot of electronics, but one of the most important part of being an engineer is letting other people take over where they have their expertise and learning how to integrate your expertise with theirs to make a cohesive project.